Hello everyone, welcome to the video, and today we're going to talk about decibels. Let's see how that's going to turn out. And there's actually a couple of laws that I want to bring in at this point that are relevant to understanding power output when it comes to sound systems and whatnot. One of them is the 3 dB rule. Actually, you know what? Before that, let me talk about because we just got done talking about how decibels are measured. Let's talk about, actually, let me throw this in as well. So you understand also how decibels work. If you're dealing with a system or a speaker that is putting out 90 dB, and then you add another speaker that adds 90 dB, goes hand in hand with the 3 dB rule, you're not going to get 180 dB. That doesn't work that way. You actually are going to get a combined output of 93 dB. And again, it's just kind of how the science works. It's logarithmic. It's not, one for one incremental. And so that, to my point, goes to the 3 dB rule. For you to have a noticeable increase in power, which means to the human ear, is 3 dB. So that's what the human ear, when you don't get past sound fatigue and you blow your ears out because you've been at a concert for an hour, whatever. But generally speaking, under normal circumstances, the human ear is going to hear a 3 dB increase. For you to achieve that 3 dB increase in power output, you have to double your power. So again, for example, if you have a 1,000-watt speaker and you're hitting 90 dB and you want to get louder, if you're cranking it up by watts, you do 1,500 watts, not going to do it. It's not going to give you a significant increase in power. To have that noticeable 3 dB increase in power, you need to double your power. So if you have a 1,000-watt speaker and you're doing an upgrade, or you have a gig and your rig is only 1,000 watts and you want to blow the paint off the back of the room, you need to double your power to have a significant 3 dB increase. And that's just the math, So bear that in mind. And the other formula, since we're talking about formulas, that I wanted to bring up is the inverse square law, which again, when you're plotting out sound system, is something that you have to bear in mind. And simply put, the further you get away from the source of the sound. So if you're, on stage and you're looking out towards the crowd, the further you get away, the sound will diminish. And the inverse square law states that you will lose 6 dB in energy, in SPL, when you double the distance away from the sound source. So for example, if you're at 1 meter, which is roughly 3 feet, and you're hitting 90 dB, you go 2 meters out, you've dropped to 84. If you go 4 meters out, you've dropped to 78. That's a huge drop off. And again, that's the math. So, and this is where line array comes in play, and depending on the size room and what sound system you have and what area you're trying to cover, you have to bear in mind what speakers you have, the power you have, the deployment of the speakers you're going to have, and how you're going to utilize it to cover said space. So yeah, again, bear in mind the 3 dB rule. If you want to go louder, you got to double your power. And bear in mind on the inverse square law that as you go further away from the source, your sound is going to significantly drop off. I guess the other thing I wanted to touch on when it comes to decibels is the A weight versus the C weight. And that's usually, I'll put up a graph. So, you know, kind of if you haven't seen it, it will be a dBA versus a dBc. And the A weight is a curve that was established to mimic what the human ear can hear. So a lot of your sound ordinances, because I know, you know, every now and then there'll be people asking questions about, well, how loud can I go? How loud should I go? Most sound ordinances that have sound limits are done to the A spec, to the dBA spec, because that's what the human ear hears. So when your meter is set to dBA, it's mimicking what the human ear hears. dBc, like in Charlie, actually takes into account more of the low end frequency. So, and there are multiple different ones that are used in different industries. So if you're, you know, at a warehouse or a manufacturing place, there's actually different decibel readings because those machines are making different noises and you want to not damage your hearing. But in sound world, we're basically dealing with dBA like an alpha and dBc like in Charlie. And I guess if you're, you know, going to a festival or a rock show where you know you're going to have a lot of low end, you know, someone's bringing out, you know, 16, 18, double 18 subs or some, you know, 21-inch subs, you kind of want to have an idea of what your low end representation is. So that's why you would measure in dBc. But most of the time we're going to be doing dBA, which again is reflective of what the human ear can hear. And kind of circling back again to where we started off with decibel levels. Yeah, your speakers are not hitting 128, 130, 132 dB. They're just not. I mean, you literally would be causing irreparable hearing damage to the people in your events if you were pushing your sound system that loud. Trust me. I know on the 2 rigs that I have out of the 4, I've put a dB meter on my mid-size rig and my large. Actually, I haven't even done my large rig yet. Honestly, I know on my mid-size rig, and I was in a very confined space with not a lot of people there, and it's a very high efficient rig. And I put the gauntlet down. I wanted to see what this thing would do. And I wasn't even in the red on mixer. I had my SPL meter out, and I was hitting peaks of 120, 121. I was actually averaging about 117. And I will tell you, after like 20 minutes, I was like, I couldn't even handle it. I mean, I cannot stress enough how loud things are once you get past, like I said, 110 is your base. Actually, here in Richmond, there's actually a ordinance where, like for outdoor concerts, you're not supposed to hit at the FOH, which is generally about 100 feet away from the stage. That at FOH, you're not supposed to hit more than 100 dB. And even that's kind of banging, you know, so you can imagine using the inverse square law, the closer you get, how loud it's going to be, you know. So again, just bear in mind, even though these specs are out here saying, oh yeah, this thing hits 132, that's not continuous. That's not a realistic number. That's not a real world number. That's an engineer number. In a iconic room, those are those rooms that, you know, are like dead silent with a specially calibrated mic in a very controlled environment. And again, I'm not denying those numbers are real, but in real world application, you're not going to the, you know, Marriott hotel and putting up some column array speakers and hitting 130 dB. It's not going to happen. It's just not real world. So there you have it. Hopefully you learned something. And obviously, if I'm wrong, by all means, you know, ask me questions or call me out, because it's the internet. That's what we do. Let me know. Thanks again for tuning in. Make sure you keep coming back to the djideasharing.com website. And again, thanks to Mike. And yeah, that's it. Hopefully, again, you guys learned something, and we'll catch you next time on the next video. Keep on spinning.